As you can see, I'm just preparing a cup of tea for myself. I just need to wait for a few minutes and my cup of tea will be ready just like that. By the way, did you notice how the lid pops up and down due to steam inside the vessel? Well, talking about thermodynamics, what exactly is thermodynamics? Let me have my cup of tea and we'll talk about it. Meanwhile, keep thinking. Everything that we do requires energy, be it my walking up and down, this chemical bubbling, or simply my talking to you. Everything requires energy, whether it's for work or for our basic life processes. And every organism has a strategy for harnessing and utilizing this energy, even a steam engine. And that is what we are going to learn about today. Today we are going to learn about the concepts of system, types of system and surroundings, the state functions and state variables, work, heat and energy, first law of thermodynamics, internal energy, heat capacity and specific heat, and key exam tips on our exam decoded section. You must also have noticed that every form of energy is interrelated, and the most common form of energy felt and experienced is heat. Let us study the relationship of heat with other forms of energy today by understanding thermodynamics, the branch of science which deals with this kind of study. Chemical thermodynamics is the portion of thermodynamics that pertains to the relationship between heat and other forms of energy such as work, both expansion or PV work and non-expansion work. Thermodynamics is based on one of the basic assumptions, that is, the universe can arbitrarily be divided into a system and its surroundings. This boundary separating the system from its surrounding can be as real as the walls of a beaker that separates a solution from the rest of the universe, or it can be as imaginary as the set of points that divide the air just above the surface of a bulb from the rest of the atmosphere. So the part of the universe under our observation is called system, and the rest of the universe is surrounding. You know what the term isolation means in English language. Now, let's see how it is interpreted in chemistry. In chemistry, a system is termed as isolated if no exchange of heat, matter or work takes place with the environment. In a closed system, the system and its environment exchange heat and work, but no exchange of matter takes place. Whereas, in an open system, heat, work and matter are all exchanged. Now there is something termed as thermodynamic process. Let's see what it is. A system undergoes a thermodynamic process when there is some sort of energetic change within the system. This change is generally associated with changes in pressure, volume, internal energy, that is temperature, or any sort of heat transfer. There are four kinds of thermodynamic processes, namely adiabatic process, in which there is no heat transfer into or out of the system; isochoric process, in which there is no change in volume and the system does no work; the third one is isobaric process, where no change in pressure takes place; and the last kind of thermodynamic process is the isothermal process, which involves no change in temperature. After understanding the thermodynamic processes, we will understand important terms used in thermodynamics, starting with heat. Heat which is represented by Q, is a form of energy that can be transferred, resulting in a temperature difference. This temperature difference is measured in terms of the heat capacity. You all know heat is equal to mass into specific heat into change in temperature. That is, Q is equal to mc delta T. Now we all know that energy is required to raise the temperature of an object. How much energy is required depends on what the object is made of. If we are going to compare how much energy is required to heat an object, we must compare it with an object which is alike. The specific heat capacity of an object gives us the energy required to raise the temperature of a unit of mass by 1 degree centigrade. Now, the specific heat of water is 1 calorie per gram per degree centigrade. Now, the specific heat of water is 1 calorie per gram per degree Celsius. Let us consider an example of an apple pie. Apple is mostly water. By how much will 200 grams of apple filling in apple pie cool if it loses 2000 calories of heat? Well, let me explain this to you. The specific heat capacity gives us the energy required to raise the temperature of a unit mass by 1 degree centigrade. Let me tell you, the word specific in physics has a specific definition. It is used for 1 kilogram of mass. So we gather that the specific heat capacity is the energy input. That is, mass times specific heat capacity times change in temperature. Now you know that the specific heat of water is 4200 joules per kilogram per degree centigrade. So you can calculate the change in temperature delta T for the apple filling in the apple pie. Now work, denoted by W, is a result of motion or mechanical change, which is a direct result of action by a force, either on or by the system. The negative sign in the overall work indicates that work is being done by the system, and positive sign indicates work is done on the system. When you run, work is done by you and energy from your system is utilized. So, in this case, a negative sign would signify that your system is losing energy. Let's take an example of a steam engine now. The steam in the steam engine is derived from boiling water or lighting other fuels like wood and coal. This steam is then used to propel the train. So you can see how the heat generated from boiling water results in work done in moving the train. Pressure into volume change, or P delta V, represents work expansion. Since pressure is equal to force by cross-sectional area, so work is equal to pressure times change in volume, delta V. When delta V is positive, then it is work of expansion. When delta V is negative, it represents work of compression or non-expansion. In either of the cases, heat is the workless transfer of energy. In case change in volume is 0, then work done is 0. Now there are 7 state functions in thermodynamics. What are these state functions? Well, a state function is a property of a system that depends only on the current state of the system and not on the path by which it got to this state. This means state function depends on the initial state of the system and the final state and is independent of the way the final state is reached. There are 7 state functions in thermodynamics. They are temperature, pressure, volume, internal energy of the system, entropy, enthalpy, and gives free energy. Also, these properties or 7 functions depend only on the initial and final state and not the method by which the state is reached. Since you already know what temperature, pressure, and volume are along with their units, let's begin with the internal energy of a system. Internal energy of a system is defined as the sum total of all the energies associated with the system. It shows that internal energy is the energy stored in a system at the molecular level. So from the formula we get internal energy is a sum total of kinetic and potential energy. The kinetic energy depends on translational, rotational and vibrational energy, whereas the potential energy depends on nuclear, electronic, positional, magnetic, electric and several other components. Internal energy E is dependent on so many energies which cannot be measured simultaneously for a system. So what we measure is the change in internal energy delta E. To measure the change in internal energy, we should know its significance. To understand this significance, we have to relate work done on or by the system. There are two ways to change the internal energy. Internal energy can either be changed through work done on or by the system and through heat absorbed or evolved. Heat is defined as the transfer of energy to a body that does not involve work or those transfers of energy that only take place because of a difference in temperature. Change in internal energy is equal to the sum of heat absorbed or evolved and the work done on or by the system. Work is equal to pressure into change in volume delta V. So, change in internal energy can be written as delta E system equal to heat absorbed or evolved plus P delta V. If delta V is 0, then change in internal energy is equal to the heat absorbed or evolved. Now you can see the meaning of change in internal energy, which is heat absorbed or evolved at constant volume. Two kinds of work are normally associated with a chemical reaction. If the change in volume is greater than 0, it is called expansion, and if it is equal to 0, it is called non-expansion, as denoted in the equation shown. Now let's quickly get on with what we have to learn next, the first law of thermodynamics. But before we do that, let's take a short break. Welcome back. Good to have you all bright and pepped up. The first law of thermodynamics can be captured in the following equation, which states that the energy of the universe is constant. A more useful form of the first law describes how energy is conserved. It says that the change in the internal energy of a system is equal to the sum of the heat gained or lost by the system and the work done by or on the system. The relationship between internal energy and work can be understood by considering an example of the tungsten filament inside a light bulb. Example of the tungsten filament inside a light bulb. When work is done on this system by driving an electric current through the tungsten wire, the system becomes hotter and change in internal energy delta E is therefore positive. To understand the sign convention for the relationship between the internal energy of a system and the change in temperature, let's take another example. Take a beaker of water in a hot plate. When the hot plate is turned on, the system gains heat from the surroundings. As a result, both the temperature and the internal energy of the system increases and delta E is positive. When the hot plate is turned off, the water loses heat to its surroundings as it cools to room temperature and delta E or change in temperature is negative. Now that we are done with the subject matter of this episode, take a look at the image on your screen. image summarizes the sign conventions for heat, work and internal energy. Here you can see that the internal energy and temperature of a system decrease delta E is lesser than 0 when the system either loses heat or works on its surroundings. Conversely, the internal energy and temperature increase delta E is greater than 0 when the system gains heat from its surroundings or when the surroundings work on the system. Here are some definitions for you. Work is equal to force into distance moved. Heat is equal to mass into specific heat and temperature change. Internal energy E is the sum total of all types of energy associated with the system. The first law of thermodynamics states that the energy of the universe is constant. Now that you have learned quite a bit for today, it's time to solve some questions to get the hang of this topic and understand it better. So let's go. With an example, define state functions. Now for the answer. State functions depend on the state of the system and not on the path. There are 7 properties of a system, independent of its path, and one of them is temperature. Assume for the moment that a thermometer immersed in a beaker containing water placed in a hot plate reads 73.5 degrees centigrade. This measurement can only describe the state of the system at this moment of time. It can't tell us whether the water was heated directly from room temperature to 73.5 degrees centigrade or heated from room temperature to 100 degrees centigrade and then allowed to cool. The other state functions are pressure, volume, internal energy, entropy, enthalpy, and Gibbs free energy. These properties depend only on the initial and final state of a system and not on the method by which that state is achieved. Now that was quite a long and important question. You know what? Some people have been complaining that I only ask you difficult questions. So I decided to have one of you ask me a question to answer.
Please define internal energy and give its physical significance.
Now even though we have dealt with this topic, let me explain this to you again. Internal energy E is a thermodynamic property of a system. It is the sum total of all the types of energy associated with the system. Internal energy is the energy stored in a system at the molecular level. The system's thermal energy, the kinetic energy of the atoms due to their random motion relative to the center of mass, plus the binding energy, which is the potential energy that holds the atom together in terms of atomic bonds. Any change in the internal energy of the system is equal to the difference between its initial and final values. The equation for any change in internal energy is the difference between final internal energy and initial internal energy, and this is also equal to the sum of heat absorbed or evolved and work done by the system or on the system. Work done is a product of pressure and change in volume. Change in internal energy of the system is equal to sum of heat absorbed or evolved and product of pressure and change in volume. If the change in volume is 0, change in internal energy will be equal to heat absorbed or heat evolved at constant volume. Let me ask some of your peers a very easy question now. Define adiabatic system.
Adiabatic system is a process in which work or matter can be transferred.
It is a process in which the energy of the system remains the same.
Well, one of you got it right. The adiabatic process involves no heat transfer into or out of the system. Now here is an easy question for you. State the first law of thermodynamics. Keep thinking over it during the break while I get back with lots of exam tricks and treats for you. back to our discussion. But before I get on with giving you a list of probable questions and ideal answers, let me state the first law of thermodynamics for you. The first law of thermodynamics states that the energy of the universe is constant. A more useful form of the first law describes how energy is conserved. It says that the change in the internal energy of a system is equal to the sum of the heat gained or lost by the system and the work done by or on the system. This is represented through the equation E system is equal to Q plus W. To do well in your exams, you need more practice. So let's head towards the exam decoded section without much ado. Had I been a fortune teller, I would have told you exactly which questions would appear in the CBSE exam this year. But then, I guess no one can predict that except the paper setter. Nevertheless, I can give you a list of probable questions that are very important and must be practiced. So here we go. Explain the significance of first law of thermodynamics for 3 marks. Describe the following: isochoric process, isobaric process, again for 3 marks. And now comes the last and the easiest one. Define specific heat for just 1 mark. That was a good list, wasn't it? Hope it gives you enough practice and a better understanding to the topic you have just learned. Well, come to think of it, a good list of questions isn't the answer to a good score. A good set of answers is. And if you are asked, what is free expansion? Explain the isothermal free expansion of a gas for 2 marks. Expansion of a gas in vacuum is called free expansion. Writing this line would fetch you 1 mark. And no work is done during the free expansion, reversible or irreversible. For isothermal process, temperature is constant. This means that both work and expansion are equal to 0. This part of answer carries 1 mark. So make a mental note of the keywords that you are essentially supposed to write for the answer so that you get the full marks as far as the question is concerned. You know the questions, you know the answers, but you still make mistakes. Today we have a guest who will give you pointers pertaining to this topic for your exams.
First point, the work done is equal to force into distance moved. Another point, the heat is equal to the product of mass into a specific heat and change in temperature. Another point is internal energy change. It is energy associated by the system.
Adding to this list of things to remember, let me add 2 more points. Always use SI units for all variables and be careful while doing the sign convention questions and make the substitutions wherever required with extreme care. That was all I had to say for this topic. Hope I have helped in making thermodynamics easy and enjoyable for you. Do log on to topperlearning.com to gauge how much you know and where you stand by taking our online tests. These tests will certainly be helpful for you. So keep thinking and keep learning.